Good morning and good afternoon to everyone out there. Thanks for joining our webinar today and or listening to it as a recording. SAS is the undisputed leader in terms of providing analytic solutions through to the enterprise in a very wide variety of industries. And so with the prevalence of their tools out there, there are a lot of organizations asking about how SAS fits into a modern data architecture that includes Hadoop, right? And Hadoop is, for those who are just learning, a fast emerging open source data management technology that is really helping organizations solve a very wide range of some old and some new kinds of data problems. And the marriage of these two technologies is enabling a whole new class of analytics. So that is really the basis for our webinar today, for myself and Brian to take you through the technologies, how they work, how Hadoop fits into a modern data architecture, along with SAS and the analytic solutions that come from SAS. So again, thank you for joining. So just a little bit about myself. I am the VP of Strategic Marketing here at Hortonworks. Been working in the data space for a long time, up and down the data stack, from analytics all the way through to storage, and have been here at Hortonworks for about 18 months. Let me let Brian, thanks for joining me today. Let me let Brian introduce himself.
Well, hello everyone. My name is Brian Garrett. I'm a Principal Solutions Architect with SAS. I've spent about 20 years in doing analytics and software development, and one of the sort of fun facts about me is that I spent several months north of the Arctic Circle years ago.
Wow, that is cool. Cold. Literally. Okay, so thanks, Brian. So what are our topics today? So brief introduction, which we've covered. Then I want to talk about what are some of the drivers for the modern data architecture. Why are we seeing this happening now? What is Hadoop's role, Apache Hadoop's role specifically in that modern data architecture? And then how does SAS kind of plug into that overall data architecture to extend the analytic functionality out through to the enterprise? So let's get going with our topic. So first is, and this is a very simple diagram, but this is an architecture that most, if not all, organizations have today. So starting at the bottom, collecting of existing sources, traditionally structured data sources coming from ERP systems, CRM systems, perhaps clickstream, even log file data in some form, but they're loading that into one of their relational systems, relational database, EDW, possibly an MPP, a scale-out system, to store and process that data. And then they're doing some additional analytics at the top layer through applications and tools, either custom-built analytics or analytic solutions from SAS or packaged analytic applications. This is that existing infrastructure. Again, very simplified view, but really represents what most organizations have today. Now, the thing about this architecture is that it is under some pressure, given the growth of data we've all heard about, or many have heard about, the so-called big data revolution. And so there is a tremendous amount of data, 2.8 zettabytes of data created specifically in 2012. So a tremendous amount of data. Amount of data is doubling every 18 months according to IDC. And interestingly enough about this data, 85% of it comes from new data types, meaning data types that organizations are looking to capture newly that they weren't capturing before, sometimes referred to as exhaust data. And that is because there's value in this data, and now with the emergence of technologies like Hadoop, there's the ability to extract the value from that data. So most of it's from new types of data that don't really fit into this existing infrastructure, this existing architecture that we see today. Interestingly, just a side note, that machine data itself specifically, that is data coming off of devices, right? Sensors that are attached to devices like aircraft engines and HVAC systems and mobile phones and power generation grids, and all the different sources of data that might come off of being generated by machines is growing at 15x. So the amount of data being created by machines, by the so-called Internet of Things, is tremendous. The net of all of this data growth, these new types of data, the machine-generated data, is there'll be 40 zettabytes of data by 2020. So huge amounts of data, and really the question is, how can organizations continue to get value out of that? How can they put in place the systems necessary to extract that value? And that, in fact, is directly where Hadoop comes in, and that is what we are calling the modern data architecture. And that is, Hadoop sits next to those existing infrastructures at the data system layer, and it allows for those emerging data sources, the ones that organizations are now looking to take advantage of. It allows organizations to capture that data cost effectively and land that data into their system and then do transformation. Now, Hadoop is complementary to the existing repositories and data management systems. In fact, it must be interoperable tightly with those systems so that it can exchange data back and forth. You can certainly put structured data into Hadoop, and you can certainly take the data that you've processed in Hadoop and move that back into the data warehouse and other systems that you're using. Now, you can also interact with Hadoop directly from the systems above, whether it's from the existing package applications, and we'll hear more about that from Brian in a moment, or even custom-built analytic applications. The net is Hadoop is a complementary component to that existing infrastructure. It's adding capability to organizations to let them do things that they couldn't do before. So let's just talk a little bit about that. Let me also take one step back and say, for those who are not familiar with Hadoop, Apache Hadoop is an open source data management project. It is an open source project managed by the Apache Software Foundation through all of the governance rules that come with that. And it is a scale-out data management platform that allows organizations to take and land data in a scale-out file system called the Hadoop Distributed File System, and then process that data through a range of data interfaces, some called MapReduce, and other forms of processing on sometimes massive clusters, 4 or more thousand nodes in a cluster. So very low cost, easy to use, low cost scale out infrastructure for processing data, again, that's complementary, and Hadoop sits really at the center of a modern data platform. Much more information about that, of course, on the Hortonworks website. So what are some of the drivers in the modern data architecture and the drivers of this adoption? One is creating new business applications, right? How do I take those new sources of data and extract new kinds of insight out of that data? And really, what are those kinds of data that we're seeing being collected? So these 6 are what we say are the most common new kinds of data. They're not necessarily new types of data per se, but they are data that organizations want to take new advantage of, right? That they decided that there is value, and they want to collect and extract that value to drive better data insight and better decisions. So one is sentiment data, right? Data that is about the opinion or feelings about a brand or product, right? So it could be expressed through blogs, through rating systems, through surveys, through a wide range of ways that organizations might express their sentiment about your products. Secondly, clickstream data, that is data about how somebody is interacting with you via your website, right? A very, very common way, probably the most common way that organizations interact with their prospects and customers is the web. So understanding what are the 5 or 10 things that somebody did before they actually inquired with you or purchased a product on your web, if you're in retail or some other similar industry, is important. And then sensor and machine data, we talked a little bit about that. Sensors are on almost everything today, growing 15x by 2020, so tremendous amount of machine-generated data. Geospatial data, analyzing information about where a product or service is being consumed, where are my customers, where are my prospects coming from, where am I delivering to, so geospecific and targeted services. Server logs, a bit understanding how my systems are running, trying to be more predictive and proactive to prevent failures and do preventative maintenance through things like server logs, and then a kind of catch-all, I'll say, of unstructured data, text and video and pictures, et cetera. So capturing that kind of information. These are all types of data that organizations are loading into Hadoop and processing with Hadoop in order to extract more value. Now, there's another common use case that I'll say that we see with Hadoop, and that is keeping existing data sources around longer, right? So there are a variety of reasons why instead of taking data and archiving it off into a tape or some other system where it is not accessible, keeping that data online longer makes a lot of sense for an organization. So an online archive is a common use case for Hadoop. Data that was once being moved to tape is now online and available to query and analyze for a variety of reasons, looking for longer-term trends or longer-term patterns in the data. Excuse me. Compliance retention. So there are in specific industries, there are reasons for keeping data online and available to meet with regulatory requirements for the government, whether it might be in financial services or some other similar kind of industry. And then finally, the ability to combine data with external or historical data, right? So there are agencies and services where you purchase additional data which will enhance the data you already have around, and Hadoop is a perfect environment for combining that third-party or external data with my existing internal data. So it might be weather data or survey data or or research information or things that or data that I've purchased that I want to combine to get new insights to help me understand better the patterns that I have. So those 6 data types plus keeping data around longer represent a substantial number of use cases that we see for Hadoop. Now, the second really driver here for adoption that we see is around modernizing the data architecture, so the overall purpose of this webinar. And you can see that by adding Hadoop into that infrastructure, and you'll hear more again from Brian, it really enables organizations to run the right workloads in the right place. So let's talk about that just a little bit more. So we see 3 requirements around driving Hadoop adoption, and those are and really which are defining Hadoop's role in the modern data architecture. So the first is integrated, and the technology must be deeply integrated with the other investments that have been made in the organization. It must enable you to leverage your existing skills, and it must provide the key services that are required to run Hadoop at scale. So let's look at each of those in turn. So firstly, the key services, right? So Hadoop is, as I said, a core storage and processing engine that enables organizations to cost-effectively store and process new kinds of data that they weren't necessarily able to do for a variety of reasons, either technological or financial. But in order for Hadoop really to be fully leveraged, it must be part of an overall platform, as we see here, that provides those other key services so that the platform can be used effectively in the organization. And those services break down into a couple of categories. One is operational services, meaning you must be able to monitor and manage and deploy this technology, and that's done through a range of additional open source projects that are packaged and bundled together. It must provide the data services, meaning you must have the ability to manage and manipulate and analyze and serve the data through a variety of methods to interact with that data. It also must have key platform services, meaning it must provide security and high availability and disaster recovery and upgradability and kind of cross-functional services available so that the operators of the system can rely on it, so enterprises can rely on this infrastructure as they're loading their data into it. And all of this must be done on any operating system or any virtual environment, or perhaps in a cloud or appliance footprint. So it has to be able to be deployed and consumed really in the mode that the organization wants to. So key services is really key for driving the adoption of Hadoop as a part of modern data architecture. The second is skills, right? So there's tremendous investment that organizations make in training and providing skills to their users and to their employees in order to make sure that they can develop new applications, that they can analyze data, that they can operate the technology, right? So there's tremendous investment is made in those skills, and in fact, with SAS's footprint, and with the footprint that SAS has, and with the number of users who are familiar, one of the key things is making sure that those skills are directly leverageable on top of Hadoop in a way that can be, if needed, transparent to the user that they're accessing that repository. And I think you'll hear more from Brian in just a moment about how kind of those skills can be leveraged in a SaaS environment. And then third, integration. So the platform must be integrated at the platform, systems, and applications layer, meaning that there must be seamless interoperability between the Hadoop technology, the Hadoop stack, and the existing technologies within the enterprise. And if those interfaces and APIs are seamless, and if the interaction is seamless at each of those layers, then that will further drive the adoption and really enable that modern data architecture to function within each of the organizations. So what that means is, when you're really applying a modern data architecture, when you're applying Hadoop into this architecture, it gives a couple different options, and we see it sort of netting out in a couple different ways. One is workload optimization, meaning there are certain workloads that are today being run in infrastructures like in the data warehouse or in the ETL or ELT tools that are more efficiently run in Hadoop. So those technologies are certainly highly valuable and have workloads that they are efficient at, but there are certainly workloads that are and should be run in Hadoop. For example, certain kinds of transformational workloads are ones that we see running in Hadoop as opposed to those other infrastructures. Now, what that means is it frees up critical cycles in those other high-value infrastructures for doing other higher-value business processing and business analysis, whilst the scale-out Hadoop infrastructure is kind of doing the low-level bulk processing and transformational workloads that are necessary. So Hadoop is enabling, in the modern data architecture, the organization to run that right workload in the right place. And that doesn't mean you go and redo complex business logic. What it does mean is there are target workloads that make more sense and are going to be much more cost-effectively run inside of a Hadoop infrastructure. So it is a complementary component. You have to analyze exactly which workloads make sense to move over, but there are substantial cost savings and technical benefits to finding how this infrastructure fits, to finding how Hadoop fits in your overall modern data architecture. And right workload, right place is one that we consistently see from a Hortonworks standpoint that many organizations are benefiting from. So with that, let me turn it over to Brian. I think we're going to switch over to Brian as the principal presenter. Yep. Take care of that, Ken. Thank you. Brian, you have the con.
Great, thank you. Well, hi everyone. What I thought I would do is actually spend a couple of minutes really talking a little bit about SAS in case you don't know, and then we'll jump into kind of how SAS leverages Hadoop and can leverage Hortonworks technology. A couple things about SAS for those of you who may not know. SAS is a large software company. We're actually the largest independent business intelligence vendor in the market. We were founded in 1976, and we have about 60,000 sites in 135 different countries. I see from a number of the Q&A messages so far today that many of you are existing customers, and thank you for being existing customers. Also want to tell you that we're in probably 90 of the top 100 Fortune 500 companies out there. And from a SAS perspective, we focus on a couple of different things. Kind of at the core of all of our products is really dealing with analytics. And to that end, we build solutions that help customers solve certain business problems. They may be domain specific, such as something in a financial service industry for something like fraud, could be risk profiling, could be something in the retail space for forecasting or price optimization. It could even be a whole set of business intelligence tools and that type of thing. So to that end, I guess we offer the full range of different solutions, everything from data management and data quality solutions, all the way through, obviously, with the analytics and business intelligence solutions. But more importantly, we've done that now at scale so that you can do analysis of billions of records to actually go get better answers, to build a better model, that type of thing. So one of the slides that you saw earlier was really that you saw presented earlier was really SAS in the modern data architecture. And we have a couple of different technologies that actually interact with Hadoop. You know, certainly this diagram is correct in that we do have a way to actually reach into Hadoop to actually simply access data. But there's another portion of that that we're especially proud of, and that is really the concept of actually running certain SAS analysis actually inside the cluster. And so, so one of the things that we will go into now is really kind of some of the different technologies that we have, how they actually work, and how they actually interact with the with Hadoop. And so, to that end, let me share out a slide here, and we will get started. Coming.
Yep.
Still coming.
Still rendering. Okay.
Perfect. Okay. Perfect. Okay. So we have several different technologies that actually interact with Hadoop. The first being the SAS Access product. The SAS Access product basically provides connectivity from SAS into underlying data that's actually persisted on Hadoop in HDFS. And to that end, it behaves very similar to many of our other Access products, whether it's Access to Oracle or DB2 or Sybase or Teradata, those sorts of products. It allows connectivity into the Hadoop cluster. And just from a drawing perspective, it provides, one of the nice things is we actually leverage Hive technology or Hive Server 2 technology to actually make a connection into Hadoop to go get at data that's been defined in the Hive metastore to actually pull data back into SAS. The net of this is that your SAS programmers can immediately leverage data that's been persisted in Hadoop in HDFS. And can actually pull that in and immediately start doing data processing on it. And so that's a very nice feature for that. A couple of other technologies that are actually probably more interesting and more compelling for us is really some of our technologies that actually operate inside the Hadoop cluster. And those can be products like our SAS Visual Analytics products, as well as our SAS High Performance Analytics offerings. For Visual Analytics, the concept is that we actually take SAS code and we deploy that actually on the individual data nodes inside your Hadoop cluster. And what we've done is we've actually designed an in-memory distributed analytical store that actually can run inside the Hadoop cluster, can leverage the CPU power and leverage the available memory across the individual data nodes. And from a user perspective, they actually simply come back to a browser-based interface to actually go and do that, to actually interact with this tool. The really nice thing about this is this allows you to leverage billions of records to actually drag and drop and actually do some of that. And so I thought I'd actually show you just a little bit of that right now. So let me share that appropriately, and I will let you see. Okay. So perfect. Okay. So in this case, this is actually our interface inside of Visual Analytics. And what we've done here is we've actually persisted data in Hadoop in HDFS, And when we started up this data, we actually lifted that data up into the shared RAM, the shared memory, across your individual data nodes. Now, to give you a feel of this particular data set, I've got about, let me actually pull up my data source details here. I've got about 1.1 billion records in this particular data set and about 46 columns. Now, one of the nice things about visual analytics is really the ability to drag and drop through and play with the particular data that you're interested in. The left-hand column actually gives you a visual representation of the types of data that we have, whether they're categories or measures, and you can just simply select those and drag and drop them. So I've selected a couple of things here of this data. I've selected some date variables, some expenses, revenue, and profit. And I'm just going to drag this over. And when I release this, we're actually going to run this analysis in memory dynamically against a billion records. And so in this particular case, you can actually see that the data popped up pretty quickly in this particular case. And as you kind of drive along some of these things, you can actually see that the particular data across all of that particular information. Now, for us, we don't simply stop with data visualization. We would actually like to get from just simply descriptive statistics to something that's also predictive in nature. And so one of the nice things that I can do is just simply right mouse click here and pull up a forecast of this particular data. So I'm going to say show forecast. And when I actually do that, it's going to do a couple of things really quickly for me. What it's actually just done is actually just calculated a particular forecast across a set of periods, in this case 6 periods in advance, and for this individual data, you can actually see that it's actually constructed 95% confidence intervals around each of those particular lines. Now, it would be great for it to just do one forecast in that time. That's actually pretty cool. But probably the more interesting thing is actually the things that you get when you press this little I button down at the bottom. When I press this, it can actually get to kind of explain what it's just done. And so in this particular case, it actually ran 6 different forecasting algorithms and then produced, picked the one, did the fits, picked the best one, and then fit that, and then showed 95% confidence intervals for that particular information. So for something like this, you know, it really gives you the ability to kind of drag and drop, pull in this information, and kind of see the types of information that you're interested in. So let me actually delete this, and we'll actually pick a slightly different visualization just for these purposes. So in this particular case, I'm going to pick some information about our facility. I'm going to come down here and grab some information about product price actual, and product price target. And in this particular case, I'm just going to drag them onto the visualization. Now, SAS Visual Analytics actually is smart enough to actually go through and highlight the right type, so kind of the best type of visualization. So although, you know, that's certainly valuable to actually pull up that information, what we might actually want to do in this particular case is actually look at this particular visualization, but look at it a little differently. So let's come up here to this particular thing and actually click on a box plot to actually take that particular visualization and render that into a box plot. And so in this particular case, what it's just done is it's taken those billion records, it's actually sorted those to figure out quartiles, filtered by particular facility of this particular data. And I can kind of slide this along to see the different types of values that I'm interested in. Now, one of kind of the more interesting things here is really to look at the underlying outliers for this. And so I can come up, simply say, show me the outliers for this data. And that's actually going to recalculate and show me targeted outliers for particular data. And the reason that that might be particularly important is you may want to just play with the data to actually see the types of information that you're interested in. So in this particular case, what I can actually do is simply open the outliers in a new data visualization. And so I've highlighted those particular data, and now what I can do is pull up and now do investigations of just that particular outlier. And so tools like this really allow you to go through and do data visualization really at scale across all of your data. And this really leverages the power of Hadoop. It leverages the power of the distributed storage in this particular case, but also leverages the power of the distributed computing in that in-memory distributed analytical store that we have. I'll show you one more visualization, and then we'll go back to some of our diagrams. You know, one of the nice things about this is really the concept of investigation. So if I grab, you know, a whole set of particular variables that I'm interested in and drag and drop, I can also do correlation analysis. So in this particular case, I'm actually going to run this. It'll take just a second. There we go. And so what it's actually just done is it's just created a 9x9 correlation matrix for particular data. And so, for example, I can actually pull up and see as I drive over particular variables, I can see relationships between those. Now, at any point in time, I can just highlight, right mouse click, and just say explore. So in this particular case, it will actually, you know, go from there, take that particular subset of data, and then go back and refit that. And so in this particular case, what I can actually do is I can actually see a distribution of this. I can actually go in and have it, for example, go through and calculate a best fit for this particular data, and then pull up the information appropriately. And so you can see that, for example, the best fit in this particular data was a cubic fit line. So tools like this allow us to leverage the power of Hadoop, and specifically the power of Hortonworks technology to actually pull up, do data visualization at scale against billions and billions of records, to actually pull up that information and see and gain insights on your particular data. Now, I don't have time to show you all of the features here for this particular technology. There's some really nice features like what-if analysis, you know, exports out to mobile devices, out to dashboards, that sort of thing. But I will point out that if you actually open a new browser window, so you don't lose this one, you can actually go to SAS.com, and you'll actually see here that we have a whole set of information out on our site about visual analytics. You can actually see videos about it, and you can even click through and we'll spin up an instance for you and you can play with it yourself. So just a couple of things about visual analytics. So with that, let me actually turn my attentions back to the particular presentation that we were in. And what you just saw in that particular case was this visual analytics where you had thin client on the left, you had a relatively lightweight mid-tier application, and you're leveraging the power of Hadoop on the back end, the computational power of the particular data nodes in your distributed Hadoop ecosystem to actually leverage the power of the in-memory distributed analytics store on this particular platform. So that's really the, you know, one of the two technologies that we have that leverages in-memory technology inside the Hadoop cluster. One of the other big ones is really our high-performance analytics offerings. And from a high-performance analytics perspective, one of the things that we did is we took individual algorithms that were taking that were very I/O intensive and CPU intensive, and we rewrote a number of those to run in a distributed manner. And so by that, I mean that what we've done is we've taken some of the statistical procedures, some of the data mining, some of the text mining, the econometrics, the forecasting, you know, even optimization algorithms. We've rewritten those so that when they're executed, they run in memory in a distributed space inside the Hadoop ecosystem. So inside a Hortonworks store. So in that particular case, on the left-hand side of the screen, you still leverage your current SAS tools that you're used to using. You still write your code using Enterprise Guide or the Enhanced Editor or even Enterprise Miner. And as you drag and drop particular nodes into that are high performance in nature, it will execute these particular algorithms in parallel, in memory, directly inside your Hadoop store. And the beauty of this is quite simple. You heard earlier we actually talked about the rapid growth of data. And, you know, it's getting to the point that you just simply can't move your data to a place to do analysis. What you really need to do is you need to reverse that, and you need to move the analytics to the data. And actually that's what this particular technology is really allowing us to do. So those particular offerings come in a variety of sort of packages. They're kind of built for, they're really purpose-built sets. It might be that you're interested in logistic regression or neural networks or variable selection, even a mixed linear programming sort of model. You might be interested in neural networks or decision trees of some sort. You might have a case where you have, you know, millions and millions of text documents, and what you want to do is you want to do text mining in a distributed fashion in parallel inside your Hadoop cluster. So we have a whole set of those, everything from local search optimization all the way back through different forecasting methods, and all of those we've worked very closely with our partners, with companies like Hortonworks to actually deliver this so that this type of technology runs well inside a Hortonworks cluster. So with that, hopefully that kind of gives you an idea of kind of some of the types of technology that we're doing. So at this point, I'm going to turn it back over to Kim, and we'll open it up for questions.
Great. Let me take the control back from Brian a little bit, and let me see. Sorry. So we're going to go to the next step. Can you see the next step?
No, not yet.
How about now?
Yes. Yes, we have it.
Okay, so a couple of next steps again before we open for Q&A. To learn more about SAS, Big Data, Hadoop, I do have a link there for you guys to kind of log in to kind of learn more about how SAS play with, you know, the Big Data and Hadoop realm. We do have this thing called the Hortonworks Sandbox, which is a one-node cluster you can download and put on your laptop and really learn and get started with Hadoop. And within the sandbox, we have over 16 tutorials that you can kind of, you know, whether or not you're new to Hadoop or, you know, a novice or intermediate level of Hadoop, you can actually learn a lot of the steps and go through our full distribution within the sandbox, along with, you know, partner tutorials as well. And then we're always updating and providing updates on our Twitter account. So do follow Hortonworks and SAS Software for any future updates like webinars, products, you know, sandbox tutorials, things like that, just to kind of keep you guys updated with what we're doing. So with that, let's open for Q&A, John.
Thank you. And just a quick comment too, Kim. So thanks, Brian, for the great presentation. I'd say that you know, it's clear that particularly in the, you know, visual analytics and high performance analytics work that you guys have done, it is enabling, just as we were saying in the theme of the webinar, in terms of a modernizing data architecture, right? You're enabling SAS and SAS users to take advantage of this new component of the infrastructure in a complementary way to the existing things. Would you say that's correct?
Absolutely. I think that, you know, one of the things that we noticed years ago was really that people were, the data was growing, that the data was outpacing, the data volume was actually outpacing, you know, the Moore's law of the computing power. And so, so one of the things that we knew several years ago is that we needed to look at this again, to continue to remain the leader in predictive analytics.
Yeah, no, that's excellent. It's really good. So as Kim said, I think there's a lot of questions that have come in, and do send your questions in. We'll try to get to as many as we can. So we have a few moments. So Kim, why don't I let you go ahead and fire off some questions.
Okay, so first question from Ron. Thanks for he said great presentation. His question is relating to the MDA. Will Hadoop ever replace the need for EDW?
So this is John here. I mean, I'll say, you know, in the short term, we'd say, you know, no, there's absolutely meant to be complementary technologies. I think, you know, there's different engineering goals between what Hadoop does and what an EDW does, and many years of engineering have gone into EDW in terms of providing, you know, what those do in terms of enterprise platforms. You know, is there an overlap in terms of the kinds of things you can do between the two of them? Yes. And will Hadoop be able to do more and more workloads? Yes. But the data warehouse design principles are pretty different than what Hadoop is designed for. That said, you know, there is overlap between what you can do between the two of them. But in terms of in terms of data modeling and the other components that data warehouse has, there's really no comparison. I don't know if you want to comment on that, Brian.
Yeah, I would agree with what you just said. I think that one of the things that we're seeing today is that Hadoop is growing very, very quickly and is maturing very quickly. Today, most of the time I find that Hadoop is great for transactions, but it's typically pretty lousy for a transactional system in just the nature of how it writes data and persists data and you change data. It's great for writing once to it, and although there's current work that's being done to improve that, to allow it to be more transactional in nature, and I know that there's a variety of projects that people are coding, spending many, many nights coding on at the moment. I think that the sweet spot that we find for that today is analyzing records that you already have. You know, the example that I give to people is, you know, if you're a major hotel chain, this is great for taking all of the history of who stayed in what room across every brand that you've had. It would, and so that would be a great use of persisting data in Hadoop and leveraging tools from Hortonworks and from us to do that analysis. In the case of a reservation system where you need to know who's going to stay in what room next week, it's probably an enterprise data warehouse is a far better use for that type of data today.
Great example.
Yeah, and so to add to that, is this person is interested in learning Hadoop and big data. How do they get started? And I think I touched a little bit on the sandbox. Why don't you go ahead and kind of provide more details on that?
Yeah, I mean, I think, well, the Hortonworks software is downloadable from our website. If you're looking to learn it and just really getting going with Hadoop, then the sandbox, as Kim mentioned, is an excellent way. There are 14 or more tutorials which walk you through the various components, including loading data and processing data. There are also partner-related tutorials that also show you how partner technologies work, and I'd say sort of watch the space for potential with SAS as well.
Good. So that we had a good handful of questions around SAS tutorial with the sandbox. So it's in the works. The other question, I guess, is for Brian. Based on your experience, on average, what percentage of data space is typically unused in a client environment that Hadoop can leverage for storing additional data?
I'd say in general, I might defer to the Hortonworks team to actually have a better idea of how much space that they're normally finding. The pattern that I see in general is that if you build it, they will come. You know, if you go and put out a bunch of data and build a set of tools that people can gain valuable insights on, more people are going to flock to it. More people are going to use it. They're going to want more of that data. And I think that the data volume is coming to the point that people are finding new uses of existing data. You know, we have cases where that we've seen where people are using you know, data off of an elevator, elevator logs of who gets on and who gets off a high-speed elevator to actually help a building management company better predict companies that are expanding that need more space and companies that are contracting that need less space. And so, you know, that's just one of those cases where they've had the data all along. They probably were ignoring it up to the point in time, and so there are, you know, a lot of valuable insights for that. Yeah,
no, thanks, Brian. I think it's a great example of machine-generated data, right, that we were talking about. that can be leveraged with Hadoop and stored with Hadoop now and taken advantage of, particularly using tools like SAS. And there's also a question I'll just address kind of because it's about data types and specifically, are there any inherent tools for processing data in Hadoop, things like clickstream and sentiment and others. There are inherent tools, not necessarily bespoke for processing those types of data. There are scripting languages and query tools that are built into Hadoop. There are tools for collecting, for example, streaming data, whether it's log file streaming from product or for a component called Flume to others for collecting streaming data like Storm that can be used to do some amount of processing inbound during the ingest of that data, and then otherwise it's landed and then do some processing once the data lands inside the system.
And along those lines, SAS does have a variety of solutions that do everything from event stream processing for complex event processing all the way through text mining and sentiment analysis and that sort of stuff from a turnkey perspective.
Super.
Great. And then to be able to run SAS on a Hadoop node, do you need a SAS-owned hardware?
I'm sorry.
Do you need your own hardware?
Oh, do you need your own hardware?
Right.
Well, no. We have a variety of deployment options. We have customers who run these types of tools and solutions in the cloud, in our cloud. We have an offering also from SAS On Demand that actually provides that type of functionality. But I guess the more important thing is that hardware is really becoming cheap, and good, stable hardware is really becoming cheap. And one of the nice things about a technology like Hadoop is it's built from the ground up based on commodity hardware. And so as a result, you can get started very cheaply. You can then grow as your needs and data grows.
Yeah, that's excellent. Kim, I'll take a couple I see popping in here, just sort of following up. In terms of images and other sentiments, so what you have to do in terms of processing that data is, you train Hadoop to read a specific data type and provide it a function to do the processing of that data. So if there's a certain kind of image processing, facial recognition, or feature extraction, or what have you, Hadoop will do it at scale. It'll break up the problem across multiple images, across multiple clusters, and enable that processing to occur at scale. But you still have to tell it what you want to do. You have to provide the function for processing the data you want, and that's true for sentiments and the other. I might also answer the question, Kim, since I'm on the roll, about the Hadoop architecture versus cloud computing. We'd actually say that you can run Hadoop in a cloud-based infrastructure. In fact, it is available through Hortonworks partners, Rackspace and Microsoft, through their Azure platform, to run Hadoop in a cloud environment. I would say the decision on where to run Hadoop, whether it's on-premise or in the cloud, would be based on where your data is principally. If the data is being created in the cloud, then you're probably going to run Hadoop in the cloud so that you're not moving data back and forth. Likewise, if you're running and your data sources are in the data center, you'll likely want to run Hadoop there. It's principally about where the data is going to be. That's going to make most sense for where you run Hadoop.
Great. So back to Brian for the demo. How do you, I know you kind of touched a little bit on the webinar, how do you use Hive to connect to SAS and access to HDFS?
Sure. Well, the SAS Access to Hadoop product allows you to make the connection to Hive or Hive Server 2. It also provides connectivity from a file perspective into HDFS. In general, we leverage the Hive client jars that end up moving physically to where the SAS processor is. And so we leverage that for the transport mechanism over to make that connection and get that data.
And does data need to be in memory before it can be used by SAS?
It kind of depends. It can absolutely stay in HDFS if you're using it from an access perspective, in that it will only come out of the HDFS storage, those data blocks that are actually holding all that data, and move across the network into SAS as needed. For tools like visual analytics and high-performance analytics, those are both in-memory technologies that are designed to run inside the data nodes of Hadoop. And so that data is lifted up into RAM to do particular processing.
Great. One other question to Brian. Does SAS VA or advanced analytics on Hadoop data nodes affect the recommended specs configuration for a data node?
Well, absolutely. You don't get something for nothing. The biggest change that we see from customers, and as we work with our partners like Hortonworks, is a technology like visual analytics and our high-performance analytics offerings are all very memory intensive. And so, from a spec perspective, we would recommend that you add additional RAM into the individual data nodes that is sufficient to lift that data into the data you're interested in analyzing into RAM to do the particular analysis that you need. Now, we have a group within SAS, which is our Enterprise Excellence Center. They can actually assist you in doing sizing and make sure that you've sized appropriately. And we also work very closely with our partners like Hortonworks to help you guys be successful.
Follow-up question on this is, what happens if available memory is less than data in Hadoop clusters?
Well, it's not about the available RAM is a limitation of how much data you can have in RAM to do processing at a time. You can certainly have petabytes and petabytes of data out in your cluster, but the odds are that you don't need to do data visualization of all of those petabytes all simultaneously. A common pattern is that you'll find someone that will have, X number of years of data that they want to do data visualization on, and they can select that, they can subset that, they can pick the variables that they're interested in and lift that data up into RAM for this type of data visualization. So it's all about sizing for the problem that you have.
Great. We actually have time for maybe 2 more questions. So the next one is, the write once, deploy anywhere. Can we deploy the same SAS code on Teradata, Amazon, or on a Hortonworks Hadoop cluster?
Well, we have offerings for things like the visual analytics and the high-performance analytics for commodity hardware such as that's running Hadoop, such as Hortonworks. We also have the same offerings can run in a variety of appliances, and so Greenplum, Teradata, Exalogic, that sort of thing, and so there is the ability to actually leverage that sort of thing. Those are about running certain particular analysis. We have some other technologies we actually did not talk about today, things like scoring accelerators that once you've developed a model and then you want to score that against, say, all of your population, we do have offerings that also run inside of Hadoop for technologies like that.
Great. We actually have a lot more questions, but let me kind of catch up with these questions via email between you, Brian, John. You guys, the webinar is being recorded, and the slides and the recording will be available on our website. Sandbox is available right now on Hortonworks' website, so go ahead and download it if you want to get started with Hadoop and how to connect to with various of other partners that we have going on right now. And then, as we go further down, I know that there's going to be a lot of integration guides and content around SAS and Hortonworks, so do follow us on Twitter to get updates on those great assets as they become live. So with that, I'd like to thank Brian and John for their time and you guys for participating. Thanks, everyone.
Thank you, Kim.
Thank you.
Brian.
Okay, bye.